So this video is about the centroid, which is a point of concurrency. Now remember, concurrent means when three or more lines intersect at a single point, and then a point of concurrency is the name of that point where those three or more lines intersect each other. The centroid comes as the point of concurrency for what we refer to as the median of a triangle. And the median of a triangle is simply a segment connecting a vertex with the midpoint of the opposite side. And so if we take a look at this, if we just draw in a triangle, and again, it can be any kind of triangle. If we draw the midpoint in, and I'm just going to estimate this, there's a midpoint of this side. That means those two are congruent to each other. And then a median is that length. And if we draw all three of them in, and we'll do our best to draw these in, they intersect at a single point, and that point where the three medians intersect each other is called the centroid. And so the centroid is just the point of concurrency of the medians of a triangle. So then we have a theorem about centroid. Now, the interesting thing is centroid is not the a center of a circle like the incenter and the circumcenter. Those are both circles, the circumscribed circle and the inscribed circle that has centers at the circumcenter and the incenter. Centroid is not the center of a circle, but it does have a nice theorem about it, and it does have an important idea about being the midpoint, which we'll get to in a second. And so first is theorem 5.8, which is the centroid theorem. And the centroid theorem says the medians of a triangle, or the centroid is 2/3 the distance from a vertex to the midpoint along a median. So it turns out that if we name these points A and B, and so our median is AB, and then C would be the centroid, the distance from A to C is exactly 2/3 of the distance from A to B. Now, that means that CB is 1/3 the distance, and so 2/3 to 1/3 is just 2 to 1. And so another way to think about it is the distance from A to C is just twice the distance from B to C. And so if A to C is B to C is x, then A to C would be 2x. And that is true along all three of the medians. And so y and 2y, and then z and 2z, or actually z is here and 2z. Now notice the longer one is always from the vertex to the median, or to the centroid. The shorter distance is from the centroid to the midpoint. And if you draw a good triangle, it's easy to see which one is going to be double the other. So when we are looking at this, there's two other parts of this that are relevant. And if we were in class, I would cut out a nice cardboard triangle, and I would use a ruler and make measurements so that I could draw in the medians and then find the centroid. And then I would take that piece of cardboard triangle, and I'd put my finger right on the centroid, and you would see that it balances perfectly. And so the centroid of a triangle turns out to be that point where it balances. Well, that is often referred to as the center of gravity. And so the centroid is also the center of gravity of a triangle. It's where you can balance it. And it's the same idea as the midpoint of a segment. If I have imagine like a pencil, and if I take the midpoint of the pencil and I put my finger right on that, we know it's the midpoint because it balances nice and perfectly. Well, the midpoint of a segment and the centroid of a triangle have that in common. And so it actually turns out that the way that you find the centroid on a graph is the same as you would a midpoint, which is you take the average of the coordinates. Instead of the average of 2 coordinates to find the median, you find the average of 3 coordinates to find the centroid. And so let me just show you what that means. And so find the centroid if A is 8, 12, B is 2, 4, and C is 10, -4. And so we'll put a graph on here and take a look at this problem. And so graphing these points, we've got 8 over 12 up, and then 2 over 4 up, and 10 over -4 down. And so this is our triangle, and we want to find out what the centroid of it is. And so to do that, what we want to do is we want to find the 2 medians of this triangle. And so I'm going to find the median along AB. And so that means I need the midpoint of AB. And so the midpoint of AB is just going to be 8 plus 2 over 2, 12 plus 4 over 2, which turns out to be, 5, 8. And so 5, 8 is my midpoint right here. And the median, remember, is just the distance from, or the segment from the midpoint to the opposite vertex. And so I know that this is 10, -4. So I've got 2 points. And whenever I have 2 points, I can always find the equation of a line. And so I would just do the slope is going to be 8 minus a -4. So I'm using 10, -4 and 5, 8 to find the slope. So y1 minus y2 over 5 minus 10, which gives you a -12/5. And so to write my equation, I can use this as my point. And so I'm going to say 8 equals the slope, -12/5. I'm just using y equals mx plus b here, times 5 equal to, or plus b. Well, -12/5 times 5 is just -12. And so b turns out to be 20. And so we get y equals -12/5 x plus 20. And that, when you look at the line, yeah, that makes sense that a y-intercept of 20 would be likely. So then let's go ahead and do the one from AC. And so AC, the midpoint of AC is going to be 8 plus 10 over 2, 12 plus -4 over 2, which just equals 9, and then comma 4. That's our midpoint. Oh, that was actually the midpoint of BC, not AC, right? No, it is AC, and so it's this one over here, yeah. And so 9 over 4 up, and so it's going to be here. And so then we're looking for this line. Well, it turns out because this is 9, 4, and this is 2, 4, this is just a horizontal line, and so this line actually has the equation y equals 4, so that one was pretty easy. So this equation is y equals -12/5 x plus 20. That's one of the medians. This is y equals 4. Well, the way that you solve the system of equations is we usually take whatever y equals in one and we substitute it into y for the other. So I can plug in 4 for y here and then solve for x. And that gives me -16 equals a -12/5 x. Multiply both sides by -5/12. And that gives me 20/3 equals x. And so if 20/3 equals x, we already know what y equals. Y has to equal 4. And so that is the centroid, 20/3, 4. But as I was just telling you, the midpoint of a line and the centroid have the same quality about them. And so it does turn out that if you just look at the average of the coordinates, x coordinate 8, x coordinate 2, x coordinate 10, 8 plus 2 plus 10 is 20. The average of those three numbers is 20/3. Divide both sides by 3. And then 12 plus 4 minus 4 gives you 12. Divided by 3 is 4. The average of the coordinates we showed is 20/3 comma 4, which is exactly what I did here to find that length. So finding the centroid, it is helpful to remember that because this idea of the center of gravity, you can just do x1 plus x2 plus x3 over 2, and then y1 plus y2 plus y3 over 2, or over 3, sorry, because you're taking the average of 3 terms, which is a really nice formula for finding the centroid of a triangle.